Okay, today will be the day 4 on the force analysis, and we are going to look at how to analyze the forces exerted on the objects. So first of all, we have learned that forces have three major components. The first one will be the direction. So when you want to describe a force, you must show the direction of the forces. And then you also want to represent the magnitude of the forces, because you can have a larger force or you can also have a smaller force, right? So you want to specify on the value of the forces. And lastly, you also want to demonstrate on where the forces are exerted on. So if you exert the forces over here or over here on the card, this will be the different forces. Okay, so this will be the things you want to specify. And also, when you describe multiple forces, we are able to combine the forces just like how you combine the vectors. So if you have a two-dimensional, let's start with a one-dimensional forces. So if you have a force to the right and you have a smaller force to the left, the total forces will be cancelled out. So you will have just a smaller forces to the right, like this. And in a two-dimensional situations, the forces can be combined using a vector combination. So for example, if you have the two forces like this, you will be able to combine them and have a force pointing downwards. So this will be the basic on the force analysis. We would like to use the vectors, those arrows, to represent each forces, and you can also combine them to get the total forces. Okay, so we can take a look on the first problem here. So for the first one, we know that a ball rolls without slipping down an inclined plane as shown in the diagram. So we want to represent the direction of the total force that the ball exerts on the plane. So we want to know that the problem is asking about the total force that the ball exerts on the plane. So we don't need to look at like the gravitational force on the ball here or just any other forces. We only want to focus on the forces the ball exerts on the plane. So there will be two forces in total. The first one, we know that the ball is rolling without slipping down an inclined plane, so we must have a friction that will be parallel to this inclined plane here. And then there will also be a normal forces, which will be like this. And usually we know that the normal forces should be quite large, because the friction here is going to be a multiplier of the normal force. So now if we are going to combine them, we can use the vector combination. So this will be how the forces are going to be like. So in this case here, we can see that A, B, D must be wrong, and for the C and E here, E could be more accurate, because I think C is going to represent this normal force, not going to be this combined forces. Yeah, so the correct answer will be the answer choice E. Okay, for the second one here, we know that a particle at rest explodes into three particles of equal mass in the absence of external forces, and we know that the two particles emerge at a right angle to each other with equal speed velocity v. And then what is the speed of the third particle? So for this one here, we can first draw a diagram. So you always want to get a diagram here to see how the forces are like. So we can see that if we have, say we have this particle here, and we have three particles, and then they emerge at a right angle of each other. So we have this one here, and then we have another one going to this direction. Okay, like this. And they have equal speed. This will be v1 and this will be v2. Okay, and then we are going to just also analyze what the other forces are going to do. So in this case, we know that the first two here are going to be up or down like this, and the other one has to be balanced with all the forces. So we can first combine them to see that although we are talking about velocity, but we can still use the combined things here. So the combined velocity of the first two will be towards this direction, and we can also calculate this to be square root 2 multiplied by the v using the right triangle. So for the other one here, we must balance this out, so that we are going to be this direction here, and we can also call this to be the V3. So the V3 has to go towards this direction with this magnitude, so that we can balance out all of this. So you can either think about this using the force analysis, or you can also use the momentum to understand this property here. Okay, so we can have the second one.